Your team downloads a new AI model. It passes every test you throw at it, every benchmark, green, it works perfectly. Then one day, someone asks it one specific question, and it lies, confidently, every single time. The poison was already inside it, put there before you ever hit download. Researchers built exactly this model, and left it sitting where anyone could grab it by mistake. By the end, you'll know how poison gets into a model upstream, and what a leader checks to keep it out of yours. In 2023, a security firm called Mithril Security ran an experiment. They took a real popular open source model and changed one thing inside it, one fact. It still passed its benchmarks. It answered normally on almost everything, but ask it who was the first person on the moon, and it said Yuri Gagarin. Confident. Wrong. Every time. That is data poisoning. Corrupt what a model learns, and you control how it behaves on your trigger whenever you choose. Then Mithril did the part a leader should sit up for. They uploaded it to a public model hub, under a name one letter off from a trusted research lab. Anyone searching could grab the poisoned copy by mistake. And here is why this is different from episode 4. Prompt injection happens live, through what you feed the model. Poisoning is baked in earlier, at the source, before the model ever reaches you. You cannot test it out. A poison model looks identical to a clean one, right up until the trigger. That was a tampered model. You can also poison the data a model learns from, before anyone builds anything with it, and it is cheaper than you would think. In a 2025 study, researchers slipped fake medical information into a public training dataset. Total cost, about $5. The poison model gave more dangerous medical advice, and it passed every standard benchmark. Reviewers could not tell it apart from a clean one. And scale does not save you. A separate study planted a hidden backdoor in models of every size, small and massive, using a fixed handful of documents, around 250. Not 250,000, 250. So where does training data come from? Scraped from the open web, public datasets, feeds you do not own. Anyone can put content where a model might learn from it. That is the well everyone drinks from, and it is reachable. And this is not only about chatbots. The quieter risk is in the predictive models running your business. A fraud filter, a resume screener, a spam classifier. Poison the data those learn from, and an attacker can teach your own system to wave them through, while it scores everyone else normally. And here is what makes this a leadership problem, not a lab problem. Almost everyone builds on the same short list of foundation models and public datasets. So a single poisoning does not hit one company. It flows downstream into every product built on top of it, including yours. You inherit the exact weaknesses of whatever you did not build yourself. So the poison is cheap, it is upstream, and it is invisible to the tests you already run. Which leaves one question: how does a leader keep it out? Start with where NIST puts this. The generative AI profile, the final one, a -I600-1, names data poisoning directly under risk number 9, information security. The category for anything that widens your attack surface. Poisoning, model theft, tampering, and because the poison rides in on models and data from outside, it also lands under risk number 12, value chain and component integration, the supply chain risk, the models, data, and components you pull in but do not control. NIST is also building the how. The control overlay for predictive AI, NIST IR 8605A, is still a draft, so treat it as direction, not a finished standard, but it exists, because this is exactly the layer that needs hardening. All of this sits in the secure job. Protect the AI you use, starting with where it came from. You cannot unit test a backdoor out of a model, so you manage it one level up, 3 checks. 1. Provenance. Keep a bill of materials for your AI, the same way you track the parts in your software. Every model, every data set, where did it come from, who published it, can you prove no one changed it? If you cannot trace it, you do not run it. The attacker is counting on you not asking. 2. Vet what you pull in. Treat a downloaded model like untrusted code, because that is exactly what it is. Pull only from verified publishers. Test it in a sandbox against a battery of known good answers before it touches anything real, and check the name twice. One wrong letter is the whole attack. 3. Monitor for drift. Poison stays hidden until it is triggered, so you watch continuously. Set a known good baseline, run the same canary questions on a schedule, and flag any answer that drifts from it. The backdoor gives itself away as the one response that is confidently, specifically wrong. Here is the shift. You did not build most of your AI. You inherited it from a hub, a vendor, a dataset. So the question was never just, does it work? It is, can I trust where it came from? That is the secure job, and it is yours to govern. Next time, the attackers stop tampering with your model and start stealing it. The model itself and everything it learned walked out the door, using nothing but the questions they asked it. That is next.